So if you see, like already created like 6 days content, that is 6 days Docker class already from my side. I have already prepared and I'm ready to present. So next 6 days. So that is 50% of Docker. I already prepared a PPT so that it will be very easy to you. So first day will be today. So there will be only theoretical parts. So from today or like from tomorrow onwards, I will start total practical.
Yeah, okay, no, sure.
So now I have already opened the day one notes. So before discussing the day one, so I just want to share you the class content, that is from today class one from to 1st May, that is 15 days. For 15 days, just a moment. Yeah, now is it clear? My audio was clear. Okay, before that I didn't attach the headset. Yeah, so if you see, like I already prepared 15 days class content, that is today, that is 17th April to 1st May. So daily we will be having 1 hour of class, that is 10 a.m. to 11 a.m. So after attending the class, you need to at least have for you 2 hours time to at least practice. Okay, if you have the 2 hours of time daily, then you can continue from tomorrow, because if you don't practice, you cannot able to learn this Docker. So you need to have dedication. So next 15 days, after 15 days, I will take you during these weeks. I will let us discuss about the doubts and all, and I will take the mock interview as well. So you need to be prepared for that, and after 15 days you need to capable enough to answer any questions related to Docker. So if you learn Docker perfectly, then after you can learn the Kubernetes. If you are perfect in Kubernetes, then you can update in Naukri. You can update your profile in Naukri and you can start attending the interviews. Jenkins, yeah, coming to Jenkins, if you at least if you started attending the interviews, you will get some idea. So first they will ask you Docker and Kubernetes. Yeah, Jenkins is easy, you can able to easily manage in the interview, but at least you will get idea how they are asking the questions and all. Then after, anyway you will learn, like while attending the interviews, you will learn Jenkins as well, but just you need to be ready to update the profile, just for the practical purpose, just for the practice. You need to attend the interviews, then you will get an idea. Okay, in the market they are expecting these things. If you get that clarity, then after you will start your preparation accordingly. So first you need to go to the market, then only we can able to know how much the cost of the prices of vegetables. So without going into the market, we cannot able to imagine sitting in the home that tomato price will be this much and all. So that's the reason I'm telling. So if you can able to learn Docker and Kubernetes, you will get somewhat, at least somewhat confidence in Docker and Kubernetes. Then after, if you attend update the profile, then you will get some clarity on the market, how they are expecting, what they are expecting. Then after, you can prepare accordingly. So if you see Naukri portal, I have already shown everywhere they are asking Docker Kubernetes, Docker Kubernetes. Then after, they are asking Terraform. So if you first, you need to learn things what they are expecting huge. So obviously Jenkins is an hot, but Jenkins is easy. You will call whatever you are doing Docker and Kubernetes, you will call it in Jenkins. That's it. So for learning Jenkins, yeah, it will take time, but compared to Docker and Kubernetes, the tough part will not play that much role in Jenkins. Jenkins is just a UI tool. So playing with UI tool, it will be very easy compared to CLI tools. Docker and Kubernetes totally CLI and you need to write scripts. Coming to Jenkins, yeah, in Jenkins somewhat you will write a script, but at the end you will operate everything in through UI. So coming to Jenkins, it will be very easy, but Docker and Kubernetes is very tough. You need to have a dedication. So even if I tell you, you may not get some points. Try to watch the recording once again. Try to do the practice. Then after, in the next class, you can come to me and ask. So from my side, I will give my best, and I will not go hurriedly. So if you see, I just taken 15 days. 15 days is too much for this Docker, but I will not tell a content heavily. So I will just cover simple topics every day. So let us don't waste our time. No, can you able to see my screen, right? There is no disturbance and all, right? So first we will discuss about the generation of running applications, how the applications was running in the industries. So applications brings revenue. Let me enable the pointer. So if you see, applications bring revenue. To make applications run, we need servers. So that means applications bring revenue means nothing but a company will earn money through applications. If you see the example, Ola, Uber, how they are earning using applications. But application at the end, where it will runs? It will runs on servers. So to make application run, we need servers. So in these servers also we have three major generations. So to run the application on servers, in this also we have three major generations. So I am just showing you the sample application architecture. So whenever you hit any website, it will go to the web server and it will collect the data from the database and it will give a reply to you. So whenever you if you go to amazon.com, first it will go and hit the web server. So for what this web server will do, it will go and collect the data. So whenever I log in into amazon.com, first it will ask me the username and password, right? That username and password, where it will be stored? It will be stored in database. So it's a typical just a basic application architecture. You no need to understand, just I am showing. So now we will check out what is this three major generations of running applications on servers. So this slide is perfect. Can I go to next slide? Is there any confusion in this slide? That's great. So if you say, I will repeat it once again. Applications brings revenue. That means companies are earning through applications. It may be Amazon, it might be Flipkart, it might be Ola, it might be Uber. But at the end, application was running on servers. So to run application in servers, we have three major generations. So let us discuss about that generations. So in that is a first generation. Generation 1 was running the application on physical servers. During 1970s, they used to run the applications on physical servers. So first they used to procure a physical server, nothing but they used to purchase a physical server, and then after taking the server, they have installed the operating system, and for this operating system there will be some license cost. So no one will provide freely, right? Whoever providing the operating system, they need to pay an amount for operating system and they need to pay the amount for the physical server as well. And then after what they will do, after installing the operating system, they will install the application. So if they are using Ola, they will install the Ola application and what are the necessary softwares they are needed. But coming to this generation 1, what is the problem is, on physical server you will invest your total amount. You will imagine that, okay, today I started my Ola application. I am imagining that in future my Ola application will become a huge hit. I will get profits. I am in that mindset. I have started the application, but we cannot imagine, right? In the market we may fail. So in the case of under usage, hardware resources are wasted. So because whatever we have invested, I have taken the physical server. If it is my application was not work well in the market, whatever I have invested, everything will be wasted. and the return on investment will be under question mark. I have invested this much of amount. If my application was become a huge hit, definitely whatever I have invested, everything will be returned back to me. But we cannot able to imagine, right, how our application will be like become a success. But now let me explain what is the disadvantage here. So if you see, we are taking the physical server. Inside that physical server we are running the operating system and we are running the application, but only one physical server you can able to run only one application. This is a major drawback of generation 1. So if I want to host another application, I need to take another physical server. Under that physical server I need to again install the operating system and I need to deploy the application. That means I am investing too much of amount for the application. I don't know whether the application will success or not, but still I am investing too much of amount in physical server and operating system. So this is the major drawback of generation 1. In generation 1 they used to take a physical server, then after they used to run only one application on one physical server. Then after we get a generation 2, that is nothing but hypervisor. So hypervisor is nothing but a company. It is providing a clone of operating system, nothing but. So install hypervisor on physical server, which will help in creating multiple virtual machines. Nothing but, if you see, if I am using a WhatsApp, I can clone the WhatsApp in my mobile as well. So I can run 2 WhatsApps in my mobile using WhatsApp clone. In the same way, hypervisor is also a software. Using this software you can able to clone a multiple operating systems. So if you see, I have taken a one physical server. In that physical server I have installed a hypervisor, nothing but a VMware software. Inside that VMware software I am launching a virtual machines. Inside that virtual machine I will run my operating system and my application. Here if you see, I am running 2 applications only on one physical server. How it is capable? Because of this VMware software. But here, coming to disadvantage, whatever the resources it is using, it is taking from the physical layer. So even though if I am running 2 applications, for these 2 applications the storage was taken huge, because here I am installing total operating system. Here also I will install total operating system. Here also I will host the application. That means storage cost will be huge. If the storage was huge, automatically my RAM will also be increased. That means I am investing double amount. Even though if it is a VMware, I can able to host 2 applications, but here also disadvantage is I am investing too much of amount in the application. So if you say, hypervisor licensing cost will be involved in additional to OS cost. So nothing but, for OS I need to purchase a license. For even for hypervisor also I need to provide an amount. So VMware will not going to give you freely, so they will charge you amount. So for that also you are investing the amount. So this is the generation 2. First generation, they are directly taking the physical server. Inside that physical server they are running only one application. And the generation 2, they are like VMware was implemented, that is hypervisor. Inside that hypervisor you are running 2 applications, okay, well and good, but you are taking the total operating system and you are running, and the storage will be huge. If this hypervisor fails, your total 2 applications will stop working. So this is the major disadvantage of generation 2. Now if we go to generation 3, here we will get a containers. So container is nothing but an isolated area created by container engine, nothing but Docker. So Docker is a company who has created this container. So inside this we have a lean OS and application runs inside the container. Nothing but it will not have a total operating system. It will have a thin layer of operating system to run the application. If you see, I have taken a physical server. Inside that physical server I can directly install this Docker. Okay, after installing the Docker I can directly run our applications, that is as a container. That means you no need to pay the amount for this operating system, because Docker is using a Linux operating system. It is a open source, and it will not take total operating system. It will take only thin layer of operating system. Using that thin layer, it will create a container, and inside the container you will run your application. So here you are just investing that, you are not investing that much. You are just installing this Docker. Using this Docker, you are creating a container. That means your major focus will be application. But coming to virtual machines, you are investing amount for VMware. You are doing payment for VMware. For operating system also you are payment, and you are investing too much of amount. But coming to here, using Docker is an open source. You no need to pay any amount. So using this Docker, you are directly creating the application. That means you are, at the end, you are saving the amount. So if you save the amount, you will play a key role in the company, because company was not wasting too much of amount. Major focus will be application. You need to deploy the application. Using that application, you will get some amount, you will generate some money. But coming to generation 1, you are investing total money in the physical server. Inside that physical server, you can able to run only one application. Coming to generation 2, okay, VMware comes into the future, you are running 2 applications, but at the end they are using physical layer itself. It will take in total operating system huge amount, and we need to pay amount for that VMware software. That's also your, that means rather than application, you are investing for infrastructure. But coming to here, you will just install a basic Docker. On the top of that, you will run the application. Here you will not take total operating system. You will take a thin layer of operating system, whichever necessary for that application to run. So this is the basic difference between generation 1, generation 2 and generation 3. You no need to understand what is this Docker, how it is running, everything I will discuss further, but you need to have some clarity. What is generation 1? Physical servers. Generation 2, VMware. Generation 3, containers. So this is the basic difference of 3 generations. Did you understand until this? Is there any confusion? You can ask. That's great. So shall we proceed to next? So I will repeat this again. You don't need to worry. I will repeat once again this topic. Now we need to discuss about microservices. So before discussing this microservices, now let me open my Paint and I will explain you. Let me open my Paint. Okay, this is a physical server. So this is generation 1. This is generation 2. This is generation 3. In first generation, they used to take physical server. Sorry. So inside this physical server, they are running the application. In physical server, so this is very important. That's the reason I am just in physical server. Run one application. This is generation 1. Coming to generation 2, we have get a VMware. So nothing but a WhatsApp clone like that. So using that you can able to create two servers. So here you can deploy your application 1, application 2, but here disadvantage is you are investing amount for yes, infra cost will be huge. If the VMware fails, your two application will stop working. Then after we will get a container technologies. So we are learning Docker. This process will be remain same. So now we are running Docker. In the future, if we get another container technology, if it very easy, and if the company started implementing using that container technology, you will, in the place of Docker, you will use different of that software, but the process remains same. So try to understand the process. In future, if Docker replaced, no problem, we will learn that. But if you don't understand this process, you will be having some confusion. So using this Docker, I can run any number of applications inside a container. So how it can able to run without using a how it can able to run using thin layer application, everything we will discuss further in upcoming sessions. You just like focus on this generation starts it. So like this, whatever I want, I can able to run the application. This is the server generation. Okay, until this, is there any confusion? Super. So if you want, I will save this image, I will share with you. Okay, yeah. So I will keep this in desktop. Server generations. So today's class, you just need to understand these things. Now I will discuss about microservices. That's it for today. Let us stop with this. So now let me create new. So before discussing microservices, I need to discuss this monolithic. No. So let me discuss, then you will get some clarity. Okay, coming to monolithic. So this is your application. So inside your application, so let me assume that we are running a e-commerce application. So inside that e-commerce application, I have a product URL, I have a add to cart, I have a payment. So treat it as a Amazon application. So I have a product. What I will do, I will add to cart in order to, then after I will do payment. This is the typical application I am running. This is called it as a monolithic. That means, let me write, on one server you deploy total application. Okay, for suppose my application was working fine. Okay, for suppose if I get a huge traffic, at that time I need to scale this, right? So if I want to scale, I need to create, okay, I need to create a clone of this another. Okay, now let me erase this. So if I want to do some auto scaling without downtime, if I don't want that, what I will do, I need to create a one more total application deployment into another server. So now let me select this, Control C. So this will be server 1, this will be server 2. That means my application will not have downtime. So if this server fail, then I can able to use this server 2. And if I am getting huge traffic, I will be using some load balancer. Using that load balancer, I will send traffic to this both. Okay, did you understand what is this monolithic approach? You are deploying your total application into one server and you are doing clone of this total application. Yes. Yes. So this is just I need to tell about this concept, that is monolithic. In monolithic, what you are doing, you are scaling your total application into one server. So here if I talk about disadvantage, now I am getting only traffic to for my product. I am getting only traffic to this product. So for that I am creating total clone of this, but I am getting only traffic to only my product page, but I am just creating the clone of add to cart and payment also. Why I need to do that? Traffic was getting from product itself, but we are running the application on one server. That's the reason we need to create a clone of this total whole application, because we are deploying this application on one server, total application. That's the reason you need to clone, take the clone of total operating system, like total, sorry, not application. Here also you are making the clone, but the cost will be huge, right? This is a monolithic approach, that is total application was deploying into one server. Even if I getting a traffic to my product, I am creating the clone of total application. Is there any possibility that if I get a traffic to only product, I need to scale for only product? I should not scale for add to cart or payment. Only for product I need to scale. Add to cart, payment will remain only one, but I need to increase the product, is there any capability, then we will discuss about this microservices. But coming to monolithic, you just need to understand on one server you will deploy your total application. So if we are getting to huge traffic, then you will just keep on cloning your total application. So did you understand what is this monolithic? Yes, 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 yes. Super, you understand. Now, I will discuss about microservices. People will confuse this. You need to understand this concept. These concepts, it is not necessary in order to like learn Docker, but if you know this basic foundation, then you will have little bit confidence. So microservices. So here also I will take the example of same e-commerce application. I have a product. Okay, I have add to cart. And I have payment. Super, yes. So if I am getting traffic, I will create a container. Yes, yes, okay, yeah. It will be automatically done by Kubernetes. You no need to worry about that. In the background, it will shut down the product container. It will create a payment container. Depending upon the traffic, it have a capability that, so if I am getting huge traffic for that, it will create automatically. Yes, yeah, if I am getting a traffic, try to create this much of containers. If I am not getting the traffic, try to disable that, try to terminate that. For that we need to write some logics in the YAML files. At the end we are telling, if I am getting the traffic, try to create this number of parts. If I am not getting the traffic, delete that this number of parts. At the end we are writing it, but in the background it is everything running automatically. But who are doing that? Conditions. Who are giving the conditions? As a DevOps engineer, we are giving the conditions. If it is doing automatically, what is the use of DevOps engineer? People just blindly ask this question. Who are writing this to do that automation, who are writing that YAML files? We are doing the YAML files. If it is failing, if it is not responding, who are going to troubleshoot? As a DevOps engineer, we are going to troubleshoot. In the background it is doing automatically, but who are controlling that automations? as a DevOps engineering we are controlling. So coming to microservices, already you told it. It's it is happy for me that you already told. So if I getting the traffic for product, I will create a product containers. Then you will be having auto scaling as well. So for suppose if whenever I hit a product container, if I am not getting response, then it will we have different product containers, so it will go and the traffic will go to the container where it was working perfectly. So this is microservices. So at the end we are saving the like at the end what the major role of DevOps engineer, we need to save the time, we need to save the money of the company. That is the reason DevOps engineer getting huge lots of package. Why? We are saving the amount of the company. If we are saving the amount of the company, at the end company will get a huge profit. If they are getting a huge profit, it is not we are getting, we should get the profit, we should get a huge amount, right? Because we are saving the so much of amount of the company, so at the end they will pay a huge salary compared to others to a DevOps engineer. That's the reason there is a demand for DevOps engineer. Why we are getting a huge packages? This is the reason. We are saving huge amount and we are doing some automations. That's the reason. So now let me, so this is, if you see, so the e-commerce application, we will be having front end and application and database. So whenever you hit any website, it will go, traffic will comes to here and it will goes to this application, and whatever the username and password, it will be stored in database. So this is a typical application. You no need to understand these things, in further you will understand, but in the background what will happen whenever you hit any website, this will happen. So if you see, this is the e-commerce application. We will be having administration and user management, inventory, catalog, cart, payments, notifications. So this is the typical application. We will be having this many topics, that is we will be having notification. If I get anything, I need to get a notification. So there will be some payments, there will be cat, and there will be catalog. Inside the catalog we will be having different items. It may be like mobile, it may be everything. So it is a typical, you can treat it as an example of Amazon. So in user management, nothing but whatever the user you have created in Amazon, it will be controlled using user management. So this is all about breaking a monolithic to multiple small services. Each microservices generally represents a module, a functionality which can run on its own. So smaller changes are possible and replacing service is easier. Each service can be differently like different technology. So nothing but in microservices, coming to monolithic, you are deploying the total application into one server, but in microservices you are deploying into different pieces, and you are deploying into order will be one container, administration will be one container, identity payment will be one container. If I am getting too much of traffic to order, I will create a order container. And one more advantage of microservices, you can write a code of order in Java language, you can write a code of catalog in Python language, so you can use a different technology. So each container can able to run in different technologies. That's the future of microservices. Coming to monolithic, you are deploying your total application into one server, you are writing everything in one language. But microservices has a capability that you can able to scale only that particular order service. In the same way, if you want to write a different technology, different language, that is also in microservices it will be implemented, and replacing will be very easy, because if you scale this order, if the traffic is not getting, we can directly delete this. So at the end, whatever So Docker was created and for microservice approach. So Docker is very much capable for microservice based deployment. That's the reason we are discussing monolithic and microservices. Why Docker? Docker will be can able to run in microservices. It will can able to create a container. It can be able to delete a container. So now what is that we need to do as a DevOps engineer? Okay, you are telling everything. You have shown the generations. You have shown the like monolithic microservices. As a DevOps engineer, what I need to do? I need to do that is I need to run the application whatever developer created as a container. How I will create a container? Using Docker. So, and another responsibility, creating container is not after creating the container we need to automatically scale that container without downtime. So ensure we can scale the containers automatically and enable CI/CD pipeline to make smaller changes frequently without downtime. Even if we have some changes, we can able to do some changes using CI/CD pipeline, and we should not have a downtime of the application. So this is the typical like role of the DevOps engineer. So that's the reason in the market they are asking Docker and Kubernetes in the combination. If you can able to know this Docker and Kubernetes, if you can able to create a container using Docker, and you can able to protect that container using Kubernetes without downtime, you are ready to crack a job. That's the reason I'm telling, just learn Docker and Kubernetes, update your profile, start attending interviews. You will start failing the interviews. You will get some confidence after failing some interviews. So what's next? So my suggestion was to try to create an account in AWS or Azure account. So from tomorrow onwards we will start from Docker. That's it for today. If you have any questions, I am ready to answer. Yes. So as I said, right, we are so that's the reason I said in the beginning itself, what is this Docker? What is this Docker? We will discuss in further classes. How this Docker can able to create a container, I will discuss in further classes. Yes. Yeah, everything I will tell. For today, you just need to understand this generations and what is the difference between monolithic and microservices. Let us go step by step. If you have some clarity on that, what is this Docker, how it was created, how can Docker able to create a container, in which how it is creating from scratch, I will explain.